The anthropic principle, also known as the observation selection effect, suggests that the universe's fundamental physical constants and age are essential for conscious life to exist. Proponents of this principle argue that if these values were different, we would not be able to observe the universe. The principle has been formulated in different ways, with weak and strong versions that depend on the types of cosmological claims they entail. The weak anthropic principle suggests that the universe's apparent fine-tuning is the result of survivorship bias and draws upon the notion of the multiverse for statistical population. In contrast, the strong anthropic principle argues that the universe is compelled to have conscious and sapient life emerge within it. Participatory anthropic principle suggests that the universe must be observed as a condition of its existence, implying one or more observers. Finally, the final anthropic principle views the universe's structure as inevitable and eternal due to information processing. The anthropic principle emphasizes that the laws and constants of the universe must accommodate the possibility of observing them. This principle was formulated in response to the observation that the laws and parameters of the universe take values that are consistent with life, rather than ones that wouldn't be compatible with it. The theme of the story is the anthropic principle, which is the idea that the universe is finely tuned for the emergence of life. While some proponents of the anthropic principle argue that a tautological foundation is problematic, others have put forth stronger variants that are contingent upon empirical verification and make controversial claims. Robert Dicke's work in 1961 noted that the age of the universe, as seen by living observers, cannot be random, but is constrained by biological factors. If the universe were significantly older or younger, it would not be able to support the formation of planets, stars, and subsequently life. Steven Weinberg and others have also offered anthropic explanations for the observed values of physical constants, which are balanced to permit the emergence of commonly found matter and the possibility of life. The story underscores the idea that the universe appears to be finely tuned for the emergence of life. The story revolves around the anthropic principle, which refers to the idea that the physical laws and constants of the universe are precisely balanced and fine-tuned to allow for the existence of intelligent life on Earth at this time. Carter's paper defined two forms of the anthropic principle: a weak version that only addressed anthropic selection of privileged spacetime locations in the universe, and a strong version that dealt with the fundamental constants of physics. Carter and Dicke resolved a long-standing issue in physics regarding the numerical relations between the physical constants by explaining that the coincidence only held true because of the existence of intelligent life at this particular time. The multiverse theory, which postulates the existence of a large collection of universes with varying parameters and laws of physics, is a radical explanation for the anthropic principle but offers a potential answer to the question of why the fundamental laws of physics take the form we observe. The term anthropic principle has been extended to cover various ideas, some of which differ significantly from Carter's original definitions. Boltzmann's proposed explanation for the universe relies on fluctuations that could create pockets of low entropy, leading to the existence of Boltzmann universes. Despite the featurelessness of most of the universe, it is not surprising that humanity inhabits a Boltzmann universe, as intelligent life can only exist in such a universe. Carter's weak and strong anthropic principles argue that our location in the universe, in both space and time, must be compatible with our existence as observers. Barrow and Tipler's definitions of the WAP and SAP differ from Carter in that they restrict the principle to carbon-based life and apply it to fundamental physical constants. The SAP is seen as the purpose of the universe to generate and sustain observers, or that observers are necessary to bring the universe into being. Lastly, Barrow and Tipler state that an ensemble of different universes is necessary for the existence of our universe. The anthropic principle has been the center of much confusion, with many misunderstandings arising from it. While some principles, like Brandon Carter's work, hold sound foundations, they are not strong enough to have any significant scientific impact. Current methodology is insufficient for deriving any observational consequences from cosmological theories. Despite their empirical testing by astronomers to address this problem, observation selection effects must be considered within a more adequate formulation. The strong self-sampling assumption, SSSA, proposed by Bostrom suggests that each observer moment reason as if randomly selected from the class of all observer moments in the appropriate reference class. However, choosing either too broad or too narrow a reference class results in counterintuitive results, and an ideal choice cannot be prescribed. To generate non-trivial predictions, the anthropic principle requires additional assumptions on the prior distribution of alternative universes. It suggests there may be other universes with different values of fundamental parameters, which would not permit life as we know it. Hence, the universe we live in may be fine-tuned for life to thrive. The observed fine-tuning is not surprising if multiple universes exist, with only a small fraction able to support intelligent life. The theme of the paragraph is the debate surrounding the concept of the anthropic principle in physics and how it relates to the fine-tuning of the universe. The anthropic principle suggests that the fundamental parameters of the universe were selected from a multitude of possibilities, which contrasts with the traditional hope of physicists for a theory of everything having no free parameters. The paragraph explores various hypotheses, including the idea of a unique universe, a multiverse, intelligent design, the life principle, and the self-explaining universe to explain the fine-tuning of the universe. The debate is ongoing, and each hypothesis resolves some issues while leaving others unanswered. The paragraph highlights the importance of the anthropic principle in understanding the origins and nature of the universe. The theme of the paragraph is the anthropic principle and its implications for scientific inquiry. The author discusses three different versions of the principle: Carter's WAP, Barrow's SAP, and Carter's SAP with multiverse, and their potential predictions. The author argues that Barrow's SAP is difficult to test because other universes are unobservable, but that Carter's SAP with multiverse can make probabilistic predictions about early phase transitions, the fine-tuning of the universe, and galaxy formation. The author also notes that the anthropic principle does not require the Earth or the solar system to occupy a privileged position in the universe, but rather posits that our observations are necessarily conditioned by our own existence as observers. Finally, the author gives an example of how Fred Hoyle used anthropic reasoning to predict the energy of an undiscovered resonance in the carbon-12 nucleus. The theme of the article explores various scientific theories and discussions related to the universe, including cosmic inflation, the anthropic principle, string theory, and the number of spatial and temporal dimensions. The investigation of the historical context of a certain prediction reveals that the carbon nucleus's level was not initially associated with life. Some critics challenge the theories presented, such as Don Page's criticism of cosmic inflation and Paul Davies' rebuttal invoking the inflationary version of the anthropic principle. Leonard Susskind argues that the existence of various vacua supports the anthropic principle, while others debate its predictive nature. Steven Weinberg sees the principle as a turning point for non-theistic cosmologists, while Jürgen Schmidhuber suggests a framework for maximizing confidence in any theory. The article also explains the significance of the number of spatial and temporal dimensions, with an anthropic argument suggesting that n equals 3 and t equals 1. The theme of the story is the relationship between spatial dimensions and the behavior of physical systems, as well as the implications of this relationship for the emergence of intelligent life. The style should emphasize scientific language and logical reasoning. Ehrenfest's discovery that wave impulses in an even number of spatial dimensions become distorted highlighted the impact of spatial dimensions on physical systems. This was further explored by Hermann Weyl, who claimed that electromagnetism could only be expressed in a four-dimensional manifold. Later, Tangerlini showed that more than 3 spatial dimensions would result in unstable electron orbitals, making it impossible for intelligent life to emerge. Max Tegmark's anthropic argument further supports this relationship between spatial dimensions and the emergence of intelligent life. Tegmark argues that if the temperature of the universe differs from 1, physical systems would behave unpredictably and prevent the emergence of intelligent life. Similarly, n less than 3 would make gravitation problematic, again hindering the emergence of intelligent life. Wei Xiangfeng's research indicates that 3 plus 1 dimensional spacetime is the marginal dimensionality that can afford a stable gas sphere with a positive cosmological constant. However, a self-gravitating gas cannot be stably bound if the mass sphere is too large. James Scargill's argument that complex life may be possible in two spatial dimensions challenges traditional assumptions about the relationship between dimensions and the emergence of intelligent life. Metaphysical disputes and speculations also arise in this context. Some, like Desjardins, interpret the universe as Christ-centered, while others, like Giberson, see an anthropogenic shift in cosmology. Bainbridge challenges Desjardins' optimism by pointing out the anthropic principle only requires the universe to be suitable for our evolution to this point, not our further progress. In sum, the story emphasizes the impact of spatial dimensions on physical systems and the emergence of intelligent life, both from a scientific and metaphysical perspective. The style is logical and scientific, with occasional suggestions of religious or philosophical implications. The focus of the book is on the anthropic principle, which the authors believe has its roots in teleology and intelligent design. They explore the writings of various philosophers such as Fichte, Hegel, Bergson, and Alfred North Whitehead, as well as Teilhard de Chardin's Omega Point cosmology. The authors differentiate between teleological reasoning and eutaxiological reasoning and propose the final anthropic principle, FAP, which holds that intelligent information processing must exist and never die out. The FAP is not just a physical statement but is also closely tied to moral values, and it places restrictions on the universe's structure. However, Martin Gardner ridiculed the FAP, and others have criticized it, and the selection effects it encourages critics dismiss it as a truism or trivial tautology that doesn't make any substantive claim. The authors regret the use of the word anthropic since it implies that the principle is about humans specifically, rather than intelligent observers in general, and principle is criticized as being too grandiose. Various critics such as Stephen Jay Gould and Michael Shermer argue that the anthropic principle's strong versions reverse known causes and effects by contending that the universe is fine-tuned for the benefit of our kind of life. For example, Gould suggests that claiming sausages were made long and narrow to fit modern hot dog buns is akin to this argument. Critics note that life appears to have adapted to the universe, rather than the other way around, as they cite vast evidence supporting life's natural selection. Opponents of this principle assert that applying it as an argument by lack of imagination assumes that carbon compounds and water are the only possible chemistry of life. However, alternative biochemistries have been suggested, and the range of fundamental physical constants may be wider than initially proposed. In addition, the creation of black holes that produce offspring universes in which the physical constants' values depend on those of the mother universe is suggested under Lee Smolin's Fecund universes theory. Some philosophers such as John Earman, Hernan McMullen, and Jesus Mosterin consider the strong version of the anthropic principle to be gratuitous speculation, whereas others like Mosterin contend that the anthropic inference from the assumption of an infinity of worlds to the existence of one like ours is flawed.